Hello, good day. Welcome to a lecture on our network security course. Our lesson targets for this lesson is first, we will illustrate how to secure device access. We will configure some routers in which someone will be given access but securely. We will also illustrate how to assign administrative roles. We will create users. We will assign and then assign these users on what roles are meant for each. Let's say for admin roles, support roles. And then our last lesson target is we will also demonstrate how to monitor and manage these devices. We will learn how to log what is happening uh, to our devices. We'll learn how to monitor who enabled this interface at this given time, for example. So before we proceed with the configuration, we'll first learn about some concepts about network or network security, in particular, the edge router security. So there are two approaches to this. The first single router approach. So this involves using a single router to handle both internal and external traffic, network traffic that is. So let's say this is your network. There is a single router in here in which it manages all the security for your local network. It manages security for your servers, for your devices, for your end devices. Okay. This router may have security features that are enabled like ACLs or access control list. It can also be a firewall. There could also be a firewall embedded on it or configured on it. Also, there could be VPNs in this edge router and network segmentation to protect the network perimeter. So this is the network that your local network area network is segmented from the internet or the network outside your local area network. So this uses only one single router, which is this one. So there could be advantages, there could be disadvantages on this. Advantages, it could be easy to manage because you're only managing one single router. Ease of use. Disadvantage, a single point of failure. If this fails or misconfiguration, then there's a possibility that other malicious entities like from the internet, from the outside of your network, can get inside your local area network directly. Okay, because the security features in this single router has been disabled, for example. Another approach is the DMZ approach or the demilitarized zone approach. This approach uses multiple routers to create separate network zones. Okay. So the DMZ sits between the internal and external networks and contains publicly accessible services. So here in this example, there is a single router. The purpose of this single router could be just routing. And this multiple routers under it could be where the security configuration has been configured, like firewall, VPNs, IDS, IPS. So it depends on the network administrator on what to configure on this DMZ approach. So this network is different. This network is also different, but they live or they reside in one single network. This is the services catered to this. Can be accessed from the outside or can be accessed from the inside. But these devices sometimes don't have the capacity to access these devices here inside the DMZ network because this is isolated. Okay, isolated, and isolated means it can serve some purpose but not ultimately some purpose for others. This router, this router can be the means of security for this virtual network. This one, this router also can be a source of security for this network. If this fails, if this router fails, there might be a configuration that this router will take over the security configuration of this network. If this fails, then probably this router can take over the security features of this network. So the areas of router security that we might consider, the first one could be the physical security. This involves the protection of the physical infrastructure of the router. You should also consider the hardware components and the physical location of your routers. So usually routers, switches are placed on a secure device just to prevent unauthorized physical access to these devices. If you place your router in the middle of, let's say, an office, a classroom, without any protection, like say physical lock, okay, then there's a possibility that some entities might just plug in a cable to the router and then log in to the router and then do something bad to your router. Okay. So without secured physical security on these routers, there's a possibility that your routers may be compromised. You also need to consider your router operating system and its configuration file security. You must keep your OS up to date with the security patches. So this is just like Windows, Linux, Android, in which there are security updates that are being published or released because there is new exploits that might have been discovered, new problems that might have been discovered by the creators of this router's operating system. You should also secure the configuration files that contain sensitive information. So there could be information inside this router in which it is considered sensitive. So you must also secure that. With this, you include or use strong passwords with encryption, and also one of the most important is to implement regular backups. So after regular backups, you should also test if your backup is working, and then backup again. Another area of router security is you should harden your router. You should strengthen the overall security of the router by disabling unnecessary services and features. Like say, for example, you don't need this service, so you disable it. You don't need IP bootp server service, disable it. You don't need these things, so disable it. Why? This could be a gateway for malicious entities to get inside your router, to get inside your network. And first and foremost, you don't need these services. So why do you need this enabled? So this is one way of hardening your router to disable these services. You could also configure access control list or ACLs so that only the authorized devices, only the authorized individuals can access, can get inside your routers. You should also enable logging and monitoring. This feature will log what is currently being done in your devices. And you can also monitor from these logs what has been done, what has been created, what has been changed, what has been updated. Logging is a very important tool to a network administrator, and this is one way to harden your router, your devices. You should also implement secure administrative access controls. If you're letting someone, if you're letting another person, aside from the network administrator, configure your routers inside your premises, there should be limits to that other user. So should be limits, there should be something that should stop another user from gaining access or configuration files in your router and other devices. And the last, you should also configure secure remote management options. If you want remote access to your routers, make it a point that this user, this device, are the only one who can remotely connect to your routers. So that will make it more secure. And with the help of logging and monitoring, then you can also determine who, when, where this person, this entity log in from. So how do you secure local and remote access? To secure local access, this was discussed a while ago, we ensure that the physical security of the router by placing it in a restricted area or possibly in a locked cabinet to prevent unauthorized physical access. It could be another employee, a curious colleague will try to access your routers. For example, you should implement strong passwords for local access to the router's console port, AUX port, or the serial console cable. So there are always default passwords in these routers or in these devices. You should automatically change it before deploying to the location. And you should also regularly update these passwords. Okay. It's standard in the main industry standards not to use this very simple passwords. So this is an example of a probably strong password. And do not use passwords for, let's say, 1 year, 2 years. Okay. You should also set a policy in which you remind users, remind admins to update their passwords, to change their passwords at a given time. And this can be done in the routers itself. So you should also enable console logging to capture local access activities. This allows for monitoring and auditing potential unauthorized access attempts. This is an example of logging wherein it is distinguished that on March 1, 8 a.m., configured from memory by console. Okay, this is what has been done. These are lines of logs that has been recorded, and so that you can monitor and audit these logs if someone has an someone tried to access your devices unauthorized. You can also do access control list. You configure this list ACLs to control which IP addresses or also networks that can access the router's management interface locally. You could set multiple IP addresses, or you could set only single IP addresses to access this device. So this depends on the network administrator. If the admin is in a remote location, do you want to let him gain access to this router? So that's a question to ask. So with the concepts that has been discussed, let's now try to configure SSH, NTP, and logging on a Cisco router. So SSH is Secure Shell, NTP, Network Time Protocol, and we should we, we also install logging on a Cisco routers. So this activity has pre-enabled or predetermined passwords. These are the passwords that you will use on the routers. For the enable, this one, and the VTY lines, this one. First is configuring all three routers with this command, router OSPF1. This is the open shortest path first router configuration and uses the process ID 1. So if you have multiple OSPFs, then this increments. The second command is this one, area 0 authentication message digest. This enables the MD5 authentication for all OSPF interfaces that belong to area 0. So this configures cryptographic authentication, not clear text authentication for the area 0. The next commands that you will be entering to the routers is we will configure an MD5 key, crypto key on the serial interfaces on the three routers and use this password for key number 1. So this command will enter the interface configuration for this serial interface. Then this command defines an OSPF MD5 authentication key, in which this is your password set, and MD5 is the type of authentication. So do this in R1, R2, and R3. For R2, there are two interfaces that needs to be configured. That's for S00 and S001. After you have configured this, to verify that what you have configured is working properly, you do this command, show IP OSPF interface, and this will display on your router. So this will have difference on R1, R2, R3, and this shows that you have configured your MD5 authentication. Next step that we should do, we configure the network time protocol. So the network time protocol is a service that is being provided in which devices can synchronize their time over the network from an NTP server. The NTP server synchronizes the devices that are connected to it so that it can have the same time, the same date for those devices. So here in this activity, first we will enable the NTP authentication on PCA. Okay, after you open PCA, click NTP under the Services tab to verify if it is enabled. So you click Enable, use key number 1, and the password is NTP PA55. They're caps lock, they're small letters. Next, we configure R1, R2, and R3 as NTP clients. So we need to configure router 1, router 2, and router 3 to connect to an NTP server which has an IP address of 192.168.1.5. So the command is just NTP space server and the IP address. So with this command, this will synchronize the router's clock to this NTP server. If you type the command show NTP status, it will show the status of your NTP or the status of your clock. The clock, if it shows clock is synchronized, then you are synchronizing your router time to an NTP server. Next, we need to configure the NTP authentication on the routers on the 3 routers also, R1, R2, and R3. First command is NTP authenticate. This will enable NTP authentication on the router. The next command, NTP trusted-key space 1, specify that key 1 is trusted and can be used to authenticate incoming NTP packets. If you can still remember the password that you use in the PC-A NTP services configuration, this is where we will define it. We issue the command NTP authentication dash key 1, and then that was MD5, and here is the password that we have configured in PC-A NTP service. So this will define key as an MD5 authentication key with the password that we have set just a while ago. Next, we will configure routers to timestamp log messages. So every time if the network administrator or someone who is configuring the router, let's say you disable the interface, the router will log it as an event. With this command, on each router, we enable detailed timestamps for these logs using date and time and millisecond precision. So if you disable your interface, logs will be enabled, and logs are enabled. The log probably could have time, date, and what you have done. Okay. So date, time, or time, date, and then what has been done. Next is we will configure the routers to log messages to the syslog server. We configure the routers to identify the remote host, and that is the syslog server, that will receive logging messages. So the command is logging host, then the IP address of the log server. We need to configure these commands on the 3 servers, 3 routers, so that the routers will send the logs to this particular syslog server. This command will configure the router to send log messages to a remote syslog server at this IP address 192.168.1.6. And then if we do this command, show logging, this will verify if logging is enabled. Okay, syslog logging enabled. So every time you do something, it will be logged, and then it will be also be sent to the logging server, in which our example in this activity is 192.168.1.6. So now let's configure the incoming VTY lines on R3. We use the local user accounts for mandatory login and validation, and we should only accept SSH connections. This configuration is done on R3 only, in which the first command is line VTY4. This will access the configuration of the virtual terminal lines 0 to 4, which represents the first 5 remote access sessions. The next command, login local, this specifies that VTY logins or virtual terminal logins must use locally defined usernames and passwords. So the username and passwords are inside the router itself. The next command is transport input SSH. This will restrict remote access to SSH only. If we do this, telnet, which is another form, another type, another way to access remotely a router, will be denied. It will be through SSH only, or secure shell. In order for us to have encryption on SSH, to have password encryption on our SSH, we need to do these commands so that it can be enabled. First, we will erase existing key pairs with this command, crypto key 0 ICE RSA. This deletes any RSA key pair that was previously generated on the router. So it will delete the key that was generated by R3, because it will start from the very beginning. The next command is crypto key generate RSA. This will generate a public and private RSA key pair on the router, which is required for enabling our connection to SSH, enabling SSH. So with this command, and then it will ask for how many bits in the modulus. You type in 1024, then press enter, and then you're good to go. To verify if your SSH is working properly or is enabled, we do this command, show IP SSH, and if you will see this line, it means that your SSH on R3 has been enabled and it is being, version 2 is being used. If you want to change some settings like timeout, authentication retries, and version, you just do these commands. First, SSH timeout 90. This sets the SSH login session timeout to 90 seconds. If after 90 seconds you are still not connected, let's say you forget to type in your password, you will be disconnected from the current SSH session, login session. Next command is IP SSH authentication -retries 2. This limits the number of SSH login attempts to 2 tries per session. And the next command is it will force the router. This will force the router to use the version 2 of the SSH only. If you're using SSH1, if you're using SSH3, then you cannot log into this router. It will only use the version 2 of SSH. So to test if your SSH is working properly, we test it from PC-C. If you do telnet, and then the IP address of the router, it will be automatically disconnected because you have only enabled telnet and enabled SSH. To try SSH into R3, we do this command, SSH -L, SSH the username, which is SSH admin, and then the IP address, which is 192.168.3.1. So this is the IP address of the R3 router. Type in the password, it will not show as you type, then press enter, and basically you are remotely connected to the R3 router. You are not physically on the router, you're not physically on the console of R3, you are using PC-C as a means to access R3. So that is how SSH works. If you want to access R3 from another router, then you can also do that. Let's say from R2. This is router number 2. You use this command, SSH-V, it means the version number 2 of SSH, which is the only version that is currently enabled on R3, and then this is the username, and then this is the IP of our R3. And then press enter. This is the password. And then basically you're connected to R3. So what has been done here is from R2, you're remotely connected to R3. So not physically, but remotely connected, virtually connected to R3. So I think that's all. That was just an example of on how to configure security options on a router, logging, and also NTP on another router. So if you have any questions, feel free to contact me during lecture hours or during my free time. So thank you and have a nice day. Goodbye.